All right, for this video, we're going to look at the next page in the packout provided with your notes. We're going to look at, you can see on this page, we're going to look at horizontal shifts when we move the graph either left or right. And on the back side of this is where we have vertical shifts when we move it up or down. Okay, with horizontal translations, the big thing you can see is how there's parentheses with the x. So if you add or subtract, and that affects the x, so it's on the inside with the x, you either move it to the left or to the right. And if you actually look at the very top here, okay, we have when a positive number is added to x, the result is translated to the left along the x-axis. So it's kind of the opposite. When a positive number is subtracted from x, the result is a translation to the right. So you would think it'd be the other way. You'd think if you would add, you would move to the right, but it's actually the opposite. Now, if we look at the first example, let's kind of think of it this way. It's a minus, so that means I'm going to shift it to the right. Think of it this way. If you have x minus 2, if I took x minus 2, ask yourself what x value gives you 0 for that. And that tells you where to shift. Well, you know that x would have to equal 2, so that's where the new vertex of the parabola is going to be. It's going to be at x equals 2. So I'm going to shift this here to the right 2 units. And there it is. This is our new vertex at 2, 0. Since it's just x, it doesn't get skinnier or wider. So from the vertex, when you go to the right one, you go up 1, and you're at 3, 1. Okay, then from the vertex, you can go to the left one, up 1. So you are at 1, 1. Okay, the next one, you have x plus 2 quantity cubed. Right away, you know if I draw the parent graph for that, it's the S-curve. The most important point for the S-curve is the middle point, because that's where it changes its shape. Now, since it's plus 2, okay, ask yourself what x value gives you 0? Well, it's negative 2. And since it's plus, I'm going to move this to the left 2 units. So I just move this to the left 2. So now instead of being at 0, 0, it's going to be at negative 2, 0, which is right there. And then, you know, if you go to the right one, you go up 1, so you're at negative 1, 1. Then from that middle point, if you go to the left one, you're going to go down 1 at negative 3, 1. And you can plug these values in. You know, let's see, this actually should be negative 1. It's a little typo there. So it should be negative 3, negative 1. Okay, let's do the next one. The next one is where we're going to get VAs and HAs. Now I have 1 over x minus 3. The parent graph for that is 1 over x. And 1 over x, this is where we have the boomerangs, top right and bottom left. And it's actually, you know what I'll do here? I'll erase some. That's not what I wanted to do. Alright, we'll fix it. Okay, I'm just going to make these dotted. Alright, you get the point. This isn't the best work of art here. You've seen how bad my drawings are. So we have top right, we have bottom left, and it doesn't hit the x and the y-axis. But now since it's minus 3, I move this 3 units to the right. So I move it 3 units to the right. The only thing that changes is the VA. Right? If you slide a horizontal asymptote to the right, it's still the same. So now you can see this is what changes right here. So the new VA is x equals 3. And it kind of makes sense because if you look, the algebraic way of doing it, if you look at the bottom, since it's x minus 3, well, you can't divide by 0. And if x equals 3, that's where it's going to be undefined. So where the values you get undefined, that's where you get your VAs. And then everything else is the same. Once you get the VA, a good rule of thumb is let's plug in 1 point to the right of VA, which is x equals 4, and 1 point to the left of the VA, which is right here, x equals 2. And if we plugged 4, if I plug this into the equation, I have 1 over 4 minus 3. Well, that's just 1 over 1, which is 1. So that's why I get 4, 1. Then if I put in 2, okay, if I put in 2 here, well, 2 minus 3 is negative 1. And 1 over negative 1 is negative 1, so that's why I have this point here at 2, negative 1. So I still get the boomerangs at top right, bottom left. Everything's just shifted to the right 3 units. All right. Okay, let's get rid of some of this right here. There's 8 problems on each side. And I think I'm going to do 3 on each of the sides. And then, as you know, you should finish up all the others on each side for tomorrow's class. All right. Okay, let's do the first one on this, the square root of x plus 2. Okay, when I do this one, its parent graph is this. Okay, that's the square root of x. Now, since it's plus 2 on the inside, I'm going to shift it to the left 2, right? Negative 2 plus 2 is 0. So I just take this point right here, and I'm going to move it to the left 2 units. So I start x equals negative 2. And if you did the math for it, if you plug negative 2 in, well, negative 2 plus 2 is 0, and the square root of 0 is 0. Okay, another good point to plug in is negative 1. If you plug in negative 1, you get, let's see here, negative 1 plus 2 is 1, and the square root of 1 is 1. So you have that point. Okay, another good point, let's see here, we got square root of 1. The next perfect square is 4. So x would have to be 2 to give me square root of 4. So 2 plus 2 is 4, square root of 4 is 2. So we're up here at 2, 2. And there's our graph. Same exact graph, it's just shifted to the left 2 units. So this point was 2, 2. This was negative 1, 1. And we started at negative 2, 0 because we shifted to the left 2 units. Okay, let's do the next one. Let me just do some erasing here to give us some more room. Okay, the next one I noticed there's an x squared in the bottom. So right away I'm going right to my good old Atari shape there. Okay, the Atari shape looks like this. They're both above the x-axis. Now this I'm going to shift to the right one. So the new VA is going to shift this way. So it's going to be at x equals 1. And it makes sense because x equals 1 would give you 0 on the bottom. You're still going to get the same HA, which is the x-axis. So this is y equals 0. And x equals 1 is the VA. Now again, good rule of thumb, whenever you get the equations that give you a VA or an HA, you want to plug in 1 point to the right of the VA and 1 to the left. So let's plug in 2. Let's see here. If I plug in 2, 2 minus 1 is 1, 1 squared is 1, and 1 over 1 is 1. So that is at 2, 1. So I just connect it. I make my boomerang. Okay, let's plug in a point, an x value to the left of the VA, which is just going to be 0. So if I plug in 0, let's see here, 0 minus 1 is negative 1, but then when you square it, you get 1. So it gives you the same thing. You're up here at 0, 1 right there. So then I get the other Atari shape, which again is above the x-axis. So that ordered pair is at 0, 1. Okay, let's see here. Let's skip down. Let's skip the next two. And let's go right all the way on the left there. The y equals x minus 4 quantity cubed. This one right here. Again, let's do some erasing. Save us some space. This is the S shape. Now again, this is the S shape. It looks like this. Most important point is this, the point right in the middle. Since it's minus 4, I'm going to move it to the right 4 because 4 minus 4 gives me 0. So this is going to be it. Let's hear 1, 2, 3, 4. And it's going to be the same shape. I'm just going to draw out the same shape. And I'm going to plot the width points. So I'm going to put in one value to the right, which is 5. And if you put in 5, well, 5 minus 4 is 1, and 1 cubed is 1. So right there, that's 5, 1. And then if I plug in 1 point to the left of that middle point, I'm plugging in x equals 3. If I plug it in, 3 minus 4 is negative 1. Negative 1 cubed is negative 1. So it makes sense. That's why I'm down here. So that ordered pair is 3, negative 1. So the S shapes are similar to the S curve, or similar to the parabolas and the V shapes. The middle point's kind of like your vertex, and then get 1 point to the right and to the left of it to see how wide it goes. Okay, the other 5 problems, you should finish this so you can stop the video right now. Do the other 5 problems right now, and you're either just moving it to the left or to the right. Okay, let's move on to the vertical translations on the back side. Alright, here we go. For this one, we're either moving it up or down. Now this is a lot easier right here. If you're adding, it's not affecting the x, meaning there's no parentheses with the x. If you're adding, then that means you're moving it up. Okay, and where does it say it? Right here. Here we go. If you add a positive number, then it slides up. If it's a number subtracted, then it slides down. So we can see this one, parabola x squared minus 2. This is your normal shape that goes through the origin. Now, since minus 2 is not on the inside with the x with parentheses, so I just move it down 2. So there it is. That's the ordered pair at 0, -2. That's the new vertex. So then we can just go to the right one and go up 1 and get 1, -1. Go to the left one and go up 1 and get -1, -1. The x cubed plus 3, well, this is our S curve. Again, most important part is the middle. Now, since it's plus 3, the middle point just goes up 3 units. So this is where that new middle point is. And then again, from that middle point, you go to the right one, up 1, you get this point. You go to the left one, down 1, get that point. And that's your graph. Okay, and then the other one, this is, again, where we're going to get VAs and HAs. 1 over x minus 1. Here's the parent graph. Top right, bottom left, you get the boomerangs. Now, this minus 1, this means it's a vertical shift of -1. So I'm going to bring everything down 1. So what changes now is the horizontal asymptote. So this moves down, it's going to be right here at y equals 1. Or excuse me, y equals -1. So there you see it. And then, you know, you can plug in points. You're still going to get top right, bottom left. You can plug in these x values. You know, for example, if you plug in this x equals 1, well, 1 over 1 is 1. 1 minus 1 gives you that 0. And then you get this point down there. Okay, let's do the same thing. Let's look at some of these graphs. And then the rest you're going to do on your own. Okay, the first one is kind of like the first one from the other side. You have square root of x. Now this is the parent graph, square root of x, which starts at 0, 0. Since it's plus 2 on the outside of the square root, it means the vertical shift. I just take this and I move it up 2 units. So it's going to start at 0, 2. I can plug in another one. Let's say I plug in 1. Well, if we plug in 1, square root of 1 is 1. 1 plus 2 is 3, so I'm going to move it up. So that ordered pair is at 1, 3. And there's your graph. Okay, let's do the next one. Next one, we see we have an x squared in the bottom. So right away, we're thinking, all right, this is the Atari shape. This is where we get the boomerangs that are both above. So this is what it normally looks. Atari shape, both above. Minus 1, I'm going to move everything down 1. So since I move it down 1, the HA is now at -1. I still have the same VA of x equals 0. So let's put that there, x equals 0. Because it's just x squared in the bottom, so x can't equal 0, so that's where you get a VA. So since x equals 0, and let me put here y equals -1, that is the HA. Since x equals 0 is the VA, let's plug in 1 point to the right of the VA. So let's plug in 1, and let's plug in -1. If we plug in 1, well, let's see here, 1 squared is 1, 1 over 1 is 1, 1 minus 1 is 0. So this is going to be the boomerang here. If I plug in -1, well, -1 squared is still 1, and 1 over 1 minus 1 gives us 0. So we're right here. So the boomerang shapes are still above. Okay, and the last one we'll do, let's skip the next one, the V shape, and let's go right to 1 over x plus 3. Okay, so 1 over x plus 3. Since it's 1 over x, this is where we have top right, bottom left. Now, since it's plus 3, I move everything up 3. So the new HA, I'm moving up 3 units. So it's going to be at y equals 3. Okay, and then I'm going to plug in 1. Okay, let's just erase this right there. So if I plug in 1, 1 over 1 is 1, 1 plus 3 is 4, so I'm going to move this up at 1, 4. And then you get this boomerang right there. So this ordered pair is 1, 4. Sorry for the sloppiness there. And then let's plug in, I still get the same VA of x equals 0, because I'm not shifting it left or right. And let's plug in -1. If I plug in -1, 1 over -1 is -1, and -1 plus 3 is 2. So I'm at -1, 2. So there it is. Let's erase the original graph. So then we get this boomerang that's below this HA. So it's still top right, bottom left. All right, so if you have numbers that are added on and there's no parentheses with the x, like this, the +4, the -2, the -4, you're either moving it up or down. If you're adding or subtracting on the inside of the parentheses with x, then you move it left or right, which was on the first page of these notes.